not taking the class that is, okay, first let me introduce myself. I'm Dinesh. You know already I gave a class on 3D and 4D printing of morphing matter. The class schedule says UV curable polymers, but I'm not taking that. Instead of that, I will be taking a class, or not a class, I would say a lab on shape memory alloys. So what are shape memory alloys? As you remember, you did an experiment or a lab session with Curve where you have worked with epoxies, right? So in epoxies, what you do is like they have their original state, then you heat it or you put in water, you deform it, cool it, and then again you put it to hot water, it goes to an original state. We will be also doing something similar to it, but here instead of using epoxies, we will be using shape memory alloys. So in this case, the shape memory alloys has two states. I call it as state 1 and state 2. There are specific names for these states, but I wanted to make things very simple, so I will call it as state 1 and state 2. Okay, so what you do, let's say you have a shape memory alloy. Before that, shape memory alloys can be found in 3 different types. It can be in form of wire, it can be in the form of springs, it can also be in the form of thin sheets. And the shape memory alloy that we will be using here, it is based on an alloy of nickel and titanium, so it is referred as 99. Okay. Let's say we have a shape. Let's say we are using a spring. So this is the state 1. Okay. What I do is I stretch it. So this state, I won't call it as a state 2, but I will call it as a deformed state. I'll call it as a deformed state. And if I heat this system, then it will go back to this state. So before going back to the state, when I'm applying heat, that state is called as state 2. And after applying heat, it goes to state 1. So the experiment that we will be doing today, we will be preparing some curvature-based actuators today. So what all things I have prepared for you is I have I call this as a U-shaped wire. And then what we will do is we will stretch elastomer. Here the elastomer is a VHP tape. Then we will bond this U-shaped actuator to the stretched VHP tape. And when we release the VHP tape, it will form a curvature. Okay, if I'm not clear, maybe I was quick. So let me write the step what we do. So we have a membrane or an elastomer of this size. Clear? We have a U-shaped wire. What we will do is we will stretch this wire, stretch this membrane. So let's say we stretch it to 60%. Initial length is, let's take the length that we will be taking. Let's say the initial length is 70 millimeters. So we will take 60, or for making the calculation easy, let's do 50%. So if I do 50%, what I will do is I will stretch this membrane to 105 millimeters. Okay. And then I will hold this at this state. And after that, I will be placing this, the U wire here. And after that, what we will do is, by some means, we will be trying to glue this U wire on this membrane. So this membrane is already tacky or sticky. To get additional bonding, we will be using a Kapton tape over it. And after that, what you do is we cut this. If we cut this, since this is an elastomer, can I say it will try to go to its original state? If it's trying to go to its original state, can I say this a new L will try to go near to L0? And when it's trying to near to go to L0, this is a layer which is strained, or I will say which is not flexible, it's rigid. But this layer is flexible. So it will try to go, when it will try to go, we will get a shape like this. And then what we do, we apply electricity to it. And when it applied electricity to it, it will try to go to its original state. But since there is an elastomer, it will try to come to it. And this is nothing but curvature-based actuators. These actuators can be used for various applications. A simple application, if I want to demonstrate, you can prepare quadruped, or I will say a robot with 4 legs. So in this, if you sequentially control this, this quadruped can move forward. You can also make a circular rolling boat out of it. Imagine that you have multiple of these actuators aligned in a circle. And if you are actuating them in a series, let's say this one, then due to the change in center of mass, it can start moving. So we are not going into applications. We will be just learning how to fabricate it and just we will be testing it. Are we clear with this? Okay, great. So just give me a couple of minutes and you can try to digest it. I'll just prepare the thing. Thank you for it. Yeah. Yeah, it's fun.
So the idea is Nash gonna do a live demo, and then people get to practice a little bit, right?
Yes.
Okay. So then I'm gonna turn on the camera again so we can actually see the demo.
How many students are we roughly?
25.
I'm thinking that should they round out on the table to see better or?
I think they are not gonna be all see it, right? But we may be able to vote for a candidate. So at least one team, right, has one person who knows the process, and the rest can still look at it through the camera. Does it make sense? How about you turn it this way so it's a little bit closer to the camera? Okay, great.
It's closer to that, but it's
It's strange.
Huh?
We don't see them.
On screen. Okay.
It's all tilted. So how about I was saying, if you guys wanna volunteer just one person per team to come ahead, see Dinesh demo, and he can demo multiple rounds.
I can do.
But it's just not possible to have all of you guys all come in front at once. Maybe one volunteer from each team come over, while the rest can also see this from big projector.
Oh,
yeah.
Yeah. Let's see.
Seeing it, right?
Yeah, but if people stand around here, they won't be able to see it. Yeah.
Really? As long as they don't stand in front of here, I think they can see it.
Oh, no, no. People sitting around there, have people standing here. They won't be able to. Maybe could relocate
I have one suggestion. We can put some of the chairs here. Chairs, so you are a little bit closer. But it's okay. I'll try my best. Like you can see things. I'll try to project things vertical. It's more easier for you guys to look, and then it will be easier for you to try. Okay. So as you remember, our demonstration comprises of 3 things. This is a stretchable membrane. This is a VHP tape. It has 2 protective layers, so we have to remove that. This is pre-cut shape memory a lot. This was prepared from sheets. And this is a guide which will be useful for stretching in a controlled way. And as you can see, it has a scale here. So that will govern what is the stretch ratio that we will be using. I have few tweezers here, a Kapton tape that will be used for adhesive finally. Okay. This VHB tape has two layers, and since I told it's already tacky, so I recommend you to always remove the red one first. And after removing the red one, you will be placing this on a stretcher. And after you place it on a stretcher, you will be removing the white adhesive layer. And second important thing is that when you are removing this red layer, once you get a hold of this red layer, you cannot do it slowly. You do it like this. If you do it slowly, then this membrane will stretch. And if it's stretched, then your initial L will be no longer, initial L0 will no longer be L0. Then with the help of the tweezers, you will be removing the second adhesive layer. And then since we will be stretching it, we don't want it to delaminate. So we'll add additional fixtures so it keep it fixed. So these are 3D printed things to, or I will say 3D printed clamps to fix it. And I have already set this to 70 millimeters. As you can see here, there is a red marking here that is fixed. So, and here it is at 0. So I have set to 70. I have more complicated things like generally I do when I do a very high stretch is I do clamp it more tightly. But right now, since we will be stretching only to 50%, we can use 2 fingers to just press it. And then since we are doing only 50%, we will take it to 3.5. And once we reach here, we will be taking this U-shaped wire.
This is the wire.
Place it. As you can see, it's tacky. It's not falling, but when you apply current, it might delaminate. So if we don't want to delaminate, so we will be securing with this Kapton tape. Anybody wants to volunteer sticking directly or wants to look? Anybody wants to volunteer? Yeah, come.
Thanks, Jason.
Yeah. So you need to put a Kapton.
Like an X?
X and no, first here. Okay. And the next one will
Should I
be.
tuck it or is that?
We can press it a little bit.
Very good.
Yeah, it's so difficult, right? Sorry. You did a good job. And now what we will do is we'll have another 2 ones. We do it in this way. Just leave little bit so that we can connect it for current.
Okay, so
Yeah.
on the very end?
Yeah. Like 5 millimeters is good enough. It's okay.
Okay.
Yeah, because if you cover the U completely, then how will we apply electricity? Because we are not using hot water bath. We will be directly supplying electric current.
So just one spot, or should I leave the spot on this leg as well?
Yeah, same.
It's Thank you for sharing.
The
And-
whole substrate is stacosite tape.
Yeah. Next, we are done.
Yeah, right now Dinesh is just cutting it off, cutting two ends.
Here you can see it's having some curvature, right? So what I want different from you guys is whoever is trying, I tried 50%, I want you to try 60, 70, and 40, and we will see the effect of curvature, like effect of the stretch ratio on the curvature. So since this membrane is elastic, initially the U-shaped wire was straight, now you have it bent. Now what we will do is we'll remove the unwanted VHB tape, cut it out, and then we can hook it up to a power supply, or we can do it directly as well.
Oops, sorry. You know?
No, I don't want people to get shocked. So we can use this substrate, and what we'll do is we'll start. Or maybe we can bend it more, and the second option is if you don't want to prepare an actuator, just play with the chef memory, is you could just bend this in this fashion, and we could just glue this here, and then we just supply electricity, and it will go to its original state. Just for as a demonstration, I will show you.
Yeah, just when you guys play with it, we are pumping in pretty solid currents into a pretty conductive wire. So the tape Dinesh is having is, yeah, it's a tape, and also it's electrical insulating.
Yeah.
Don't touch it directly when you are triggering it, basically. You can get a shock.
Yeah. So this is this is in the deformed state, and now when I apply current,
I think people don't see it.
oh, thank you.
Only the first row can see it, perhaps.
Uh,
If you want to move closer to the camera, maybe it's a little bit better. Yeah, yeah.
What? Okay.
And this shape you can manually make it into a different shape too,
Yeah,
right? You
I
can-
did this I did a slight bend. If you want to bend it like very bad or crumble it and then apply current, it will still recover it to the original shape.
So in a way, it is a metallic version of the shape memory polymer we played with, and it's conductive, so you can use electricity, and it's reversible, so you can do this multiple rounds.
And whoever wants to try,
So the plan now is we want to provide people opportunity to try it, right?
yes,
I think rather than whoever, we can have it a little bit organized. Maybe 2 teams come. We have 8 teams, so then we can do 4 rounds. Does that sound like a good idea?
yeah, I have planned it for 8. We can try for like, let's say, let's start with like 2 teams, like maybe like 2 persons from 2 different teams come. One may have a look, or maybe they help each other and do it. And then if time permits, then another 4 can come. So
It's more about now it's 10:50. We end at 11:30. So we have 40 minutes,
I think,
but we want 10 minutes to talk about project, right? We have 30 minutes.
okay. So let's start like have two people from two different teams and stuff.
Why don't we have 8 people coming? Sorry.
8?
Yeah, just come. Because if you only have 2 people, then what about the rest of the 6? We
Okay.
will have. Okay, guys, just 2 team come over, and we're gonna get started. Let's go with number. Team 1 and 2.
So I have a question.
Yes.
Actually, sorry. I'm very sorry. We need Dinesh to do the demo, otherwise these folks.
No, they will do it.
But I think because it's a very not informative.
Okay,
You have to pay attention to safety.
okay, I will do that.
Okay, I can answer your question.
Okay. So track the collaboration.
Anybody who wants to try or take a lead, start.
Okay.
And wherever you have problems or hiccups, or I will say, one guy stretches, second and third guy places and sticks, and the next guy will cut, and the last guy can apply electricity. So everybody gets a chance to do something. Does it make sense? Go ahead.
Is this like the 0 state?
Yes.
So peel off the red first.
Yeah. I think you did it. You have a calculator.
Oh. Oh, I didn't. Okay, so I go off the back one. That makes sense.
Just put it back, you will not be able to use it.
Okay, I can throw this out. Maybe someone else should try. Sorry about that.
It's okay. Okay. You lose the chance.
Yeah, I lose my chance. I really thought I had the right layer to open my mouth.
It's okay, since you're doing it for the first time and I just demonstrated once. If you want, I have a tweezer.
User might be helpful. Being right here.
Or till then, if somebody just wants to play with the nitrile wire bending, apply current, that's also fine. Yes, of course. I will do it.
It's
No, it's
exactly.
I've been working a lot with this. That's the reason. Huh? The tacky here. Tacky down, and then you carefully remove the top part of the tweezer. It's okay. It's okay. I also
I'm
break a
trying now.
lot.
I mean, the food's already gone. May as well.
Yeah, you can.
It's okay.
Slow. It's okay. Yeah, just be careful that you don't poke yourself with the pizza. Okay. Next guy can clamp it, stretch it. This time.
And
Just put 2 fingers here. Here.
and I go to 3.5.
Yeah, you can go to 4.2. So we are doing right now 60%.
it starts from.
Yeah, it starts from 0.
Okay.
Yeah, now just place one, no keys. Yeah, I can do. And probably somebody can glue it.
It's been built.
Yeah, yeah,
Right. Anyone wants to take it out?
yeah. And then you will take it down like this, like this. But you need to keep, let's say, 5 minutes there so we can apply current to it.
Oh, okay.
Yeah, take a lead. If you don't take, you won't get a chance.
You want my? You did a good. Okay.
You want to play with that one? It's an additional adhesive that we are putting. So when we supply current, and if it's a fast one, then it can delaminate, right? So it's like we are securing it, like gluing at 2 places. Yeah.
So you want to leave some wire exposed or?
It's okay, we can cut it later. It's okay.
Oh, I see. Open at 2 different. Yeah.
You don't want to do cutting, you want to actuate.
Just close this. Close
Yeah.
to the end.
Yeah.
Pay attention to time. We have about 10 minutes per team.
Okay.
So I think for the rest who are bit free, we can also try to make it as a wire, right?
Yeah, that only I'm doing.
Okay, great.
Don't touch here. You wanted to you bend this,
Oh,
right?
sure.
You want to do that one? I'll just,
Don't touch the electrode. I
Yeah.
can do this, yeah.
don't put continuous. One should be touched continuously, and the second one will be
Gentle.
gentle.
Where is sparkling?
Yeah, connect.
It maybe.
It doesn't matter. Yeah, I think so.
Cool.
Yeah, so if anybody wants to play the perform the way you want, and then just apply it. Okay. Yeah, we can do bending or something more.
Is the sparkling normal? Is that too much the current? We can lower the current maybe.
Do it in your like comfort zone. What did you do? It's not working.
Is it not on?
Don't continuously, right? That's cool because there's spark. The spark is concerning.
Should we lower the voltage? Yeah.
Yeah, because it's like sudden contact.
Why can't we use lower current and just continuously?
Yeah, we could do that.
Yeah.
Because that make more sense to me.
Okay.
And you can switch off the power supply whenever needed, right?
Yeah. Okay.
Yeah, let's give it a try.
If anybody wants to play with this, till then I'll make this ready. Actually, wait till-
It's switched off now.
Yeah, for sure.
Okay, yeah, get both connected.
Yeah.
Yes, I mean, worst case is we burn a, let's get the current low, right? You know, she's the current low enough. Remove your hand. Okay, good, great. Right? Yeah, this is what we want. Much more decent this way.
Yeah.
Who's gonna do that? That's like a crazy scientist.
Yeah, no, actually, I was planning to bring a transistor or something, but then thought like we won't have it that time to do.
Yeah. Anybody here knows electronics? A little bit? Okay. Yeah, no, I mean, I just mean if we want this to be controllable, you just need to connect it with the, yeah, like a transistor or a relay, any sort of things you can turn on and
Who
off
wants
power
to do it?
supply.
Yeah, you try this one and
Let's just make sure to turn off the power.
we don't offend it. It was like offended because of the first one.
Oh, yeah, not that.
Nice.
No, full continuation.
Yeah, turn it off.
Do you want to try to play with this guy or this guy?
Oh, sure.
This guy?
It's already.
Yeah, or you can do whatever shape you want.
I guess we can try this.
On it. No, on. Cool. Thank you. Good job, guys.
All right, team 3 and 4, right? Which is team 4? So we don't, and 3? Team 3? Great.
No, this was already. Okay, guys, just so what we can do is
Team 5 also. Only first half. Sorry, 2 of the team 5.
okay.
Huh? Great, then come.
Okay, some of you, what you can do is you can twist the way you want and just play so that everybody is occupied doing something. Somebody will make a device, new device, and somebody will play with the older ones. And once this device is ready, you can play with this one. Right? Okay, so I'm laminating, I'm removing the adhesive layer because I saw that I have limited ones for the class today. So I thought I will just remove one layer and the other layer you can still remove. Yeah, this one is connected. So if you want to see just the change, you just on this. And the next what you can do is you can deform this in any shape and yeah, you can bend it, twist it.
How much I can do.
Yes.
Just a lot. Whatever.
And then what you do, you change the connection.
Oh,
Yeah, you see there is one.
Wait, I wanted to.
Hey.
Wait, hold on. Yeah.
Island.
Yeah.
I want to be sure. I don't want you to get shocked.
Oh yeah. I had a both
And
teams
then
now.
with the help of Lisa, you need to remove
Yeah,
this layer.
how was it?
It was good. It was my first.
Be careful, don't hit your child.
I only know about the room in one hall, not the one in that's it.
Outside, yeah.
Yeah.
You guys can also play with that till then these people are preparing. So just to get a feel what's going on.
I think like this sample.
Good sample?
Oh.
Yes. And then place that. You put your fingers here and you need to move this. So this is at 0, this is 70. So let's say you 140. Yes, you can go. So you will go 11.5 on this side and the other side.
You can do 100% stretch.
Does it get warm when you turn it on?
Yes,
Oh,
yes,
okay,
yes, yes.
okay.
Yeah. So because I think you can do this by also putting in hot water.
Right, yeah.
Yeah, but I didn't want to do hot water.
Good. Of course, yeah.
And you can go more wilder, like for example, if you want continuous actuation, you connect it with transistors, resistor, and then you give impulse in like milliseconds. And then it will
How far away do I have to keep holding it?
yeah, I think you went to, let's do 7.7. So you go like it's 110%. You don't, you keep this off, okay?
Yeah.
Before touching it.
Okay, yeah. I checked it.
Yeah. Yeah. Yeah, somebody else will come and cut a couple. Go ahead. And you can take a help of somebody to.
But I was going to be the running.
So if you want to make a shape shifting thing that's more portable, like you don't want
Yeah, you can use batteries.
use what?
Batteries.
Oh,
small
batteries.
Small
Oh.
lipo batteries.
So does it only react to electricity or
Heat.
any form of heat?
Any form.
Yeah.
Yeah. I think the VHP tape is also tacky, so probably not allowing me to go.
Oh, yeah.
Yeah, because I didn't wanted you guys to bend this one like this and only this one to bend the way you want. It's okay.
You guys want to do the next step?
Oh,
Oh. I'm not sure what the next step is. I believe
yeah,
you guys
just
from the sides.
start it.
Okay. Oh, you were up close. Like here?
Try to be as close as
Oh,
possible.
the yellow.
Yeah, find that scissor is not so difficult.
Okay, here we go. Ah, oh no. Sorry, what do you call this? There we go.
Capron, polyamide. It can resist, it can resist, I think, 200 or 300 degrees.
Oh, what is it?
Polyamide.
Oh.
So do you see, since it had a stretch, it should have some curvature.
Yeah.
So the reason why are doing this, so when we activate for small time, it will stay, turn straight, and as soon as you off it, it will again go to bend. So you don't need to bend it. That's the reason why we have this technology. This is more because we have higher stretch. And now, since you have fabricated it, somebody can apply contact. 1 second. And you off it, and if you give it some time to cool, it should come little fast. Yeah.
But how come this thing go all the way down?
Huh?
To become flat? How come this thing go?
There might be like it's already a deformed a lot, or the energy that we are applying is enough. What I can do is,
All right, folks. So this is the teams. Too small, huh?
yeah, it has. Like for example, if you do a lot of times and if you are not giving enough cooling time,
they're able to
then it
do,
can forget this memory.
thinking of the technical balance and interest and stuff. But if you have any, like special request, please come to talk to me and Stephanie, like right now.
I think we have one more group left or two.
We have a few more group, but for the rest of the folks who haven't seen the demo and play with it, can you come up now? I believe it's gonna be team 6, 7, and 8. And for the rest, we're kind of waiting. You have a little bit time left before the class ends. Maybe you can try to, chat with your teammates. And there is a final, the assignment, right? I'm gonna send an email as a reminder as well to clarify things. Yeah, team 5, 6, 7, 8. Actually, yeah, team 6, 7, 8 come up.
So we actually formed a team of 3, we just forgot to add it on the form.
Ah. Which one?
So I'm in T10.
Or how about you guys?
It has, you need to put the festival down. Fine. Yeah.
This is different from the epoxy in that the neutral state is still quite flexible.
Okay. Oh. It's okay. It's okay. Don't worry. Okay. I want. You can take one view. Oh no, wait. First, this, and then the other side. Yeah, you do it, and now you can decide what touch ratio you want.
Let's go on to your quiz.
Yeah, go. You can go. Like you have until 11.
How much?
11, 11.5. You can go.
This is 7.
Yeah.
Slowly.
It's okay. Okay. Excuse me. Actually, two can play just with the wire.
Okay.
You can perform the way you want. You can perform this wire the way you want. And then what we do is we connect this. And it's supposed to show the thing. This one has to be
Okay. It's like,
yeah, band, whatever you want to do.
Oh,
Yeah, it goes. It goes more actually. You can go.
let's make sure that we have enough width at the end. Yeah.
Then you can connect that.
Does the polarity?
So,
Okay.
you can connect both. Whatever you want.
You're approaching the width of the neutron.
Yeah, but just we need to be one thing in mind. Since you're touching it, this width will go down, right?
Okay.
It should be higher than.
I think
It's
we are.
really good. I don't know.
Huh?
This is
9, and
so you need to.
Oh, yeah.
Okay.
we just dropped it.
Oh, I just turned it on.
Yeah.
Oh,
Whoa.
neat.
Do we need to plan out the wires?
No. Just to put.
How to forget?
Wait, yeah, it will be a little hot. Just,
Oh, okay. I was just curious, like,
Wait, if you put it that way, it's gonna have a little smooth.
yeah, little. And now you can put the fish, but now to cover everything that you keep a little part open so you can have a little connection. Yeah. Now this is cool if somebody wants to deform it any other way or just want to upload the file.
So that bending actuator, if it's well made, is supposed to be reversible, right?
Yes,
Are there any functional reversible?
they are, but actually the people have deformed it and also. There was one good one, but I think when we were doing
Don't keep up your panic. You need another way that we can introduce rigidity while it's not active. Like if we want this state to be a bit more rigid and flexible. But yeah, I'm wondering, like,
Can I try
when you apply the
something?
power, is it too kind of, is it more rigid and flexible?
actually, it is flexible at its crystalline state, at its atomic state, but you cannot feel that flexibility. Yeah.
Yeah.
It's nickel platinum. It's called 90 or 95 or 99.
Like if you were like,
Okay,
okay,
we'll
what's
check that
the
later.
boost to that part? It's like,
Okay.
oh, I'm not doing it. I mean, I'm not.
Congratulations.
That is.
No, okay. Yeah, and somebody can, you can connect it on.
Like just connecting the nodes. And
Oh. Wait, hold on, don't touch it. It's hot. Yeah, when we are making the actuators out of it, we are giving current only for 200 milliseconds. 11 volts, 200 milliseconds, but right now I reduced the voltage.
yeah, does it help to get a resistor on that?
Yeah, we could add resistors. Yes, when you are putting transistor, yeah, we do that. Just this warm, nothing.
Yeah.
So the
Did we burn it?
makes the active state
Okay.
more,
Huh?
that's the more special makes the active state.
Yeah, initial curvature will be more. And then you will have high force. If you know, then it's go like that. But if it's
I might have just, I mean, I already talked about this, I just forget, but like why are this particular material, like, I get like, you're fixing into one state and then you're like forcing it back into the other state. But wait, why does the material go back again? Like why
Yeah,
does
this one?
electricity or heat do it? Is it because the specific nickel titanium material, this is how it responds to heat?
like for example, if you compare this to a state, let's say this is the original
Yeah,
state,
yeah,
and then you bend it,
yeah,
you apply electricity, it goes to straight, right?
yeah.
But
But
then if you don't put this stretchable layer, it will not go back on its own.
okay.
So the reason to put this is so that you don't need to deform again. It goes here and automatically once you off the current, it will go to this state because of that.
Oh, well, yeah, that makes sense because like the tension from the
Yeah.
tape is bringing it back. But I guess I was just wondering like why the heat makes it go back to the.
Oh
what he
yeah.
said. Yeah.
So in this, this substance has two crystalline states.
Okay.
Like if you go at an atomic level,
Yeah.
one is called as Martenstein state, and second one is called as austenite state. So the one of the state is very stable, and when you apply heat, there is a transition from state one to state two.
Okay. Yeah, that makes sense. So it's in the structure that
Yeah.
that's like the specific material of the wire.
Yeah, so it goes from, I will call this as a flexible state.
Yeah.
When you apply current, it goes to the rigid state. or whatever.
Okay. Yeah, that makes sense. And is there like a specific, it's just like a heat threshold or something where it doesn't, or is it like gradual or-
There will be, like, for example, for this material, the threshold is around, depending upon the thickness and the concentration of nickel and titanium. To deform it permanently, you need to heat it at like 600.
Oh, okay.
Not just like pull itself back to like,
We'll try, I think.
Yo. Oh, okay. Yeah.
that would be cool.
You
We
better
don't have
plan.
cold, but I think,
Wow. Okay.
yeah.
Yeah. Alive. Yeah, good call. Good call. That is so dope. It really is. Yeah.
Yeah, but I think we deformed it a lot. It goes back very well if you give enough cooling and enough triggering time.
Yeah.
In a controlled way, it goes very well back to its initial state.
That makes sense. I mean, even just like the weight of the clamps and everything starts to lot. So it's wow, cool. Thank you.
Yeah, you enjoyed it. I'm happy.
Yeah,
Yeah.
no, definitely. And
That's really cool.
yeah, you also, I think you explained the process and everything.
Yeah, Dinesh is a very knowledgeable chemist
Yeah.
who knows anything 3D printing. So
Oh, that's awesome.
Yeah, due to limitation of, I had more couple of ideas to do, but due to time constraint, I choose the very simple one.
Yeah. Well, you did it. You guys hit your time mark. It's before the end of class. I think you got your perfect. Yeah, thank you very much.
thank you.